My name is Anna McLeod, and we're now going to talk about hemostasis. Bleeding always stops. And we're going to divide this into 3 short videos to cover each of the main steps involved in normal hemostasis. I don't have any relevant conflicts of interest to disclose. So our end of week objective is to understand the normal process of hemostasis. And in this module, we're going to, at the end of this, you should be able to describe the role of the blood vessel, platelets, von Willebrand factor, and clotting factors in hemostasis, and describe the components and process of primary hemostasis. We cannot begin to talk about disorders of hemostasis or bleeding problems or clotting problems until we work our way through what happens normally. And in this picture, you see fibrin strands. This is the goal of hemostasis, to form a clot and prevent you from bleeding to death. Within the clot here, you see platelets in purple and red cells that are also all play an important role in hemostasis. Some definitions. Hemostasis is the arrest of blood flow from or within a blood vessel. And when we say hemostasis, we're really implying the normal process. A surgeon in the OR may say, I have good hemostasis, implying that there's no excessive bleeding, but there's also no excessive clotting. Thrombosis is a term we use to describe the formation and propagation of a clot within a blood vessel. And when we say thrombosis, we're generally implying that there's a pathologic process going on. There's a problem going on. Okay, normal hemostasis has to do 2 things. It has to be fast, otherwise we just bleed to death. It also has to be localized so that we don't clot to death. If you cut your hand, you want your clotting system to turn on right there where the damage is, but you don't want it to turn on clotting all the way up your arm. It has to stay localized so that it doesn't cause excessive damage. There are really, in general, 3 steps. There's primary hemostasis. And primary hemostasis is the process of the blood vessel shutting down, the first thing that happens. And that's because you want to reroute the blood, not lose any more out of a damaged blood vessel. And you want to form a platelet plug. That has to happen quick. It's a temporary, fast way of stopping you from bleeding to death. It isn't going to solve the problem long term, but it's the first quick thing that has to happen to get bleeding under control. And that's really where we're going to focus this first part of the module. Secondary hemostasis, we'll talk about in the next part, is really the process of turning on clotting factors to make that fibrin clot that you saw in the picture. But there has to be a mechanism for breaking up that clot. Otherwise, through our lives, every time we hurt ourselves or we had bleeding, we'd have clot that was never resolved. That would never work in the long run. So we also have a process called fibrinolysis, which is the inhibition of coagulation and fibrin clot breakdown. This allows us to clear clot once things are under control and heal damaged blood vessels. Okay, now these very simple animations that I have here are just to try to focus on the main concepts. And in this picture, you see a blood vessel, and it's lined by endothelial cells. But here you see that something has come along and ripped open the blood vessel. The endothelial cells have been lost, and the subendothelium has been exposed. There's been damage. The first thing that happens in hemostasis is a platelet plug gets formed, and it comes along and plugs the hole, and it gives you quick, temporary relief from bleeding. But that isn't designed to last a long time. And unless something else happens, it's going to break down and you're going to start to bleed again. The next thing that has to happen is secondary hemostasis. And secondary hemostasis is the process of making that clot. It kind of cements the platelet plug in place and gives you a more long-lasting hemostasis or prevention of bleeding. The next process, as we said, is fibrinolysis, so that you can get rid of that clot and heal that blood vessel. Okay, a little more about primary hemostasis. Primary hemostasis is very important. Lots of things can go wrong, and lots of drugs that we use are designed to block primary hemostasis. So in primary hemostasis, you have to have a blood vessel. It has to constrict down, and it has to be able to keep the blood from leaking out. You have to have platelets. They have to be in a good number, and they have to work. And now we introduce another factor. This is something called von Willebrand factor. Von Willebrand factor is a complicated protein that does lots of different jobs. But it also is the problem in a very common bleeding disorder called von Willebrand disease that we'll talk about later in the week. So we need these three things for normal primary hemostasis to occur. Okay, remember that I said the whole goal of primary hemostasis is to make that platelet plug. And in order for that to happen, you have to have three things going on. AAA, adhesion of platelets to the damaged vessel, and that's where von Willebrand factor is going to come in. Activation of platelets. Platelets have to get turned on and start to secrete all sorts of things, get really activated. This is the step at which ASA works to block platelet action. And then those platelets have to stick together and aggregate to actually form the solid plug. And I think of this as AAA to the rescue. So imagine that you are driving down to Florida with your family. It's March break, traffic is crazy, you're in the middle of the highway, traffic is going very, very fast, and your car breaks down. AAA comes, pulls you to the side of the road, gets your family out of the car safely and off the highway. The only thing that's happened is you're out of immediate danger. You still didn't get to Florida, your car's still broken sitting on the highway, but you're out of immediate danger. And that's really what primary hemostasis and the platelet plug do. All right, how does that actually happen? So here we are back in our blood vessel. And now you see that in addition to the endothelial cells, we have some platelets, those little white dots floating out in the blood. And in fact, because platelets are small, as you saw in previous videos, and red cells are big, the platelets actually get pushed out to the side of the blood vessel. And they kind of do surveillance, rolling along the endothelium. When they come to a damaged area, like we see here, then the signals are all going to go out that there's a problem. And the first thing that actually happens is von Willebrand factor is going to play a big role now. Von Willebrand factor is circulating in the blood. It's also stored away in endothelial cells, and a little bit of it is also packed away in platelets. So it's in lots of places so that it's ready to go if there's damage. And as soon as this exposed endothelium comes up, then von Willebrand factor binds. And it binds to the exposed proteins. When it binds, it goes from being a big blob that just sits there or floats around, as you see in the picture at the bottom right, to being stretched out. It forms a bridge. And as it stretches out, it exposes a receptor for platelets that are rolling along. And as those platelets come along, they bind. This is platelet adhesion. As soon as they bind, they get activated. And as they activate, they all start talking to each other, they recruit more platelets, and now they all stick together and aggregate and form the platelet plug. So none of that can happen without von Willebrand factor acting as the bridge between the damaged endothelium and those platelets that are rolling along. And these are just other ways of looking at that so that you have a good picture in your head. In platelet adhesion, we have platelets which have a receptor on their surface called GP1B that's always there, looking for the receptor on von Willebrand factor to tell it that there's damage. So von Willebrand factor binds to those exposed proteins like collagen. It stretches out, the binding site for GP1B is exposed, and the platelet binds. Platelets then activate, and platelet researchers would go crazy with me simplifying this like this. This is a very, very complicated multi-step process, but in fact what really happens is they go from being nice little round balls to having all these pseudopods and totally changing their shape. They also expose new receptors on their surfaces, and in fact, the surface of the platelets itself changes. They become an active surface. The actual phospholipids flip and change with this process. As a result, there are new receptors on their surface, GP2B3A, that allow these plates to sort of cement each other together and form that plug. And that's the process of platelet aggregation. So the platelet plug is important for stopping you from bleeding, but actually it has another role. That activated platelet plug now provides a surface for secondary hemostasis. And in fact, without those changed phospholipids, secondary hemostasis couldn't go on. It needs that surface for the whole next set of reactions we're going to talk about to occur. And this is another way that your body keeps hemostasis extremely localized and stuck down right to where that damage is. Secondary hemostasis we're going to talk about in the next video, and it's really the process of activating one clotting factor after another to form the fibrin clot. And it's what traditionally called a coagulation cascade, although I'll explain to you it's really in reality more of an explosion than a cascade.